Okay, students. So, just I've tried using the new smartboard to record this. It has failed 6 times. So here it is, 5:30, 3 hours after school's out. I've been trying to do this, and so it has not worked. So what I have to do now is I've had to have all the work written down. I can only talk you through it with the work written down because it's not working. Hopefully the IT person, Miss Horton, will be able to figure out why it's not working, so in future ones it'll work properly. So I have done one from each major section here. So example number 10 says draw and label an angle to fit each description. So it wants an acute angle, which means between 0 and 90 degrees. And it says called angle JIH. We know the middle letter is the vertex, so the I has to go there. The J and H go on the rays. It doesn't matter. I could have put the H there and the J there. It doesn't matter. Okay. Next, down here at 14, it says name all the angles that have V as a vertex. So there's the V as the vertex. We have this angle 2, this angle 3, and the large angle. So other words, other names for angle 2 are angle DVE or EVD. Okay. Other names for angle 3 are EVF or FVE. And for the large angle, we only have two names, either DVF or FVD. Notice you cannot call it angle V because there are three angles there, the two small ones and the large one. We could call it over here, we could name the angle. We'll do number 6 here, name the angle in 4 ways. You can call it angle 4, angle F, because there's only one angle here, or angle GFE or EFG. There's your 4 ways. Okay. And you only can call it the angle by the single letter because there's only one angle here. But down here we have 1, 2, and the big one, 3 angles associated with V. So you cannot just use V. I've warned you about this already. The safest way is to use 3 letters. All right, next page. Here we have the segment addition postulate. So again, this segment plus this segment equals the whole segment. It tells me the whole segment is 32. This side is 20, so we can call this x. If I want to write out an equation, it'd be x plus 20 equals 32. Subtract 20 across, and you get 12. Now, you don't have to write an equation. I'm sure most of you are smart to know that you can just go 32 minus 20. That's right, 32 minus 20 equals 12. Okay, we come down here now. This is the hardest section right in here, so we'll do number 16, where there's some overlap involved. Okay, so it wants the length of BD. BD is from here to here. Here's D and there's B. So this red one here is BD. But we don't have from here to here. We have this whole length. So there's an overlap of 2. That's a 2 right there. So when we add this length plus this length, we have to subtract off this 2 piece right here. Okay, so it becomes this piece plus this piece equals the whole piece. So that's where this minus 2 part comes from. So 2x minus 4 plus the 2x minus 3 for this whole piece minus that 2 off equals the whole length, which is right down here, of 3x minus 1. We combine like terms. On the left side, we get 4x minus 9 equals 3x minus 1. Subtract the 3x across, that gives you 1x, or just x, same thing, and add the 9 across. 9 minus 1 is 8. I go back and read the directions. It didn't just say solve for x. I need to solve for BD. Well, BD is this right here. So 2 times 8 is 16 minus 4 is 12. So the length of BD, or the distance from B to D, is 12. I can guarantee I'm right by plugging back in the other ones. 3 times 8 is 24, minus 1 is 23. So the whole length is 23. Okay. So if this length here is 12, then from here to here must be 11. How do I get that 11 there? If I plug in here, I have 2 times 8 is 16, minus 3 is 13. So this whole length is 13, but I subtract off that 2, and that'll give me this piece from here to here. 13 minus 2 is 11. So you have 11 plus 12 is 23. There's your check. All right, and last page, oh no, second to last page, angle addition postulate. So similar to the segment addition postulate, except for there's angles. Again, the first ones are easy with just numbers. So it tells me this is 50, this is 62. What's the entire big angle? Add them together and you get 112. Very easy. Come down here, the harder ones where you have algebraic expressions involved. Here it tells me this angle right here is 45x minus 1. This angle right here is 23x. So if we add them together, it tells me the whole angle is 135, the whole big angle. So adding the two small ones together gives me the big one of 135. Combine like terms, 68x. Add the one across equals 136. Divide by 68 on both sides, and you get x equals 2. Go back and read the directions. It only asks for x, so it can stop right there. If it asks for one of the angles, I'd have to take that 2 and plug it into it. So that's what these ones are. And lastly, it says name the type of angle. Okay, let me go ahead and erase all this here for you so you don't get confused. And I'll mark it as I go here. Okay. Okay. So it says we're gonna, like I said, I'm just doing one. Name the type of angles. A and E. This angle is A. This angle is E. Okay. Now these are on the same side of the transversal. One's interior and one's exterior. That's the definition of corresponding. And that's why I've written corresponding angles here. Now I went ahead and wrote down all the types we've dealt with so far. We have alternate exterior angles, alternate interior angles. And so these are the abbreviations for them. And you wrote those down in your notes already today. Or yesterday. Corresponding angles, same side, SSI, same side interior angles, also called consecutive interior angles. Consecutive means one after the other. We've had linear pairs. Remember, a pair is two, creates a line, first part of linear. And two pairs that form two angles that make a line, and a line is 180 degrees, so that means they're supplementary as well. And we had vertical angles, and vertical angles are equal. Well, alternate interior angles, alternate exterior, and corresponding are all equal. So the only two that you have to be worried about being not equal or congruent, same idea, are the same side interior angles. I showed you why it's easy to remember that. If you call it same side interior angles, it starts with an S, so it must be supplementary. And the other word, just all you gotta do is remember the word line. Line we know is 180 degrees, so that is going to refer to you with two angles, adding a line, that's going to be supplementary. Okay, and that will come into play in the next section down right here. So if I go down to here, it says fill in with either congruent, remember that means equal basically, or supplementary, which means two angles that add to 180. So each one of these you're either saying congruent or supplementary. So I chose number 7. Look back up here at G and B. Okay, here's G and here's B. Aren't those same side and interior angles? By the way, coming back up here, I circled these here for a reason. If when you pronounce it, you say the word exterior, that means both angles must be exterior. If I say the word interior, as I do in alternate interior angles, both angles must be interior angles, inside. If I say interior here, again, both angles must be inside the parallel lines. Corresponding doesn't have that, so that's why we have for corresponding, one is interior and one is exterior, and they're not adjacent because, for example, if they were adjacent, E and H, we already know that's called a linear pair. So it can't be corresponding because E and G are a linear pair, E and H are a linear pair. So it can't be corresponding. One interior, one exterior, and not adjacent to one another. Okay, so going back to here, G and B. G and B right here, those are same side interior angles right there. Starts with an S. We know it's supplementary, adds to 180 right there, and you write the supplementary in there. And lastly, again, using the original drawing right here, every problem deals with it. A and F, we look at the relationship between A and F. A and F, those are alternate exterior angles, okay? Both of them are exterior angles, so it has to have the word exterior in it, and they're alternate as well. Alternate means diagonal. You know, as we see here, alternate exterior angles are equal, so we go ahead and set them equal to each other. That equals that, so I wrote it up here. I subtracted the 3x across, got 5x. I added the 38 across. 38 plus 9 is 47. Last step, divide by 5 on both sides. And I can leave it as 47/5 because that is reduced fraction, or I can change it into a decimal and get 9.4. All right, that ends this lesson. Almost 10 minutes. Now you can do the worksheet that I'm sending home if you want to work on it ahead of time tonight or in class tomorrow.